All right, here are solutions for the first perfect problem for Math 211 for, what is this, Winter 16? The idea here, it's an easy problem to state, kind of hard to solve. You're asked how many ways can you pay someone $1,000 if you only use $10 bills, $5 bills, and $1 bills. The answer is a lot, but you probably want to be a little bit more specific than that. We did a problem kind of like this in a worksheet, but it was a lot less than $1,000. It might have been $1 and we were using quarters, nickels, and dimes or something, but something related. I think the easiest way to attack this problem is to start to make a list. But don't try to list them all out, there'll be too many, but maybe you can recognize a pattern when you're making a list. So let's make a list, and more than just a list, it's going to be a systematic list, meaning be really careful with how you order these things so you make sure you don't miss any. So make a systematic list and find a pattern. So it's even like start to make a systematic list and find a pattern. Anyways, we need $1,000. We are using $10 bills, $5 bills, and $1 bills. So let's make a big table here. Maybe this is the number. So I think the easiest way to do it is to fix something. So fix the tens. So for example, if we paid in all tens, we would use 100 tens. And if we used 100 tens, we wouldn't use any fives or any ones. That would be one way that we could do this thing. However, another way that we could do this thing would be to use 99 tens. If we use 99 tens, we'd have $990. So we'd need 10 more dollars. And so we'd have some options in terms of how we did that. We could do that with 2 fives and no ones, or we could do that with 1 5, but if we only use 1 5, we need 5 more ones, or we could use 0 fives, in which case we'd need 10 ones. So you might think that this isn't getting us anywhere, which is a fair observation. But I think we're starting to see a pattern here. Note that there is exactly one way to do this. Maybe I'll make this a different color. One way to do this when we used 100 tens. But there were 3 ways to do this when we used 99 tens. So what if we use 98 tens? Well, we had one way, and then we had 3 ways. What's the next number in this sequence? Kind of hard to tell. You might guess something, but really you probably wouldn't feel too good about a guess at this point. So let's just go ahead and list them out. If we used 98 tens, that's $980. So how much more do you need? You need 20 more bucks. Well, how many fives? You could get 20 bucks out of 4 fives, and then no ones. Or you could get 20 bucks by doing 3 fives and 5 ones. Or you could do 2 fives and 10 ones. Or you could do 1 5 and 15 ones. Or you could do 0 fives and 20 ones. So we're up to what, 5, 6, 7, 8. We've listed 9 possibilities in our list here. But really more important than that is realizing that there were 5 ways to do this if we used 98 tens. There was 1 way with 100 tens, 3 ways with 99 tens, 5 ways with 98 tens. This kind of looks like a pattern, right? 1, 3, 5, it looks like the odd numbers. Are these in fact the odd numbers? Well, I don't know. It is. I mean, I do know, and they are. But you might not be comfortable enough to make that conclusion quite yet, so let's do one more. What if we had 97 tens? 97 tens is $970. That leaves $30 to pay. So you could do that with 6, 5, 4, 3, 2, 1, or 0 fives. And some number of ones that you could fill in here. I guess 0, 5, 10, 15, 20, 25, and 30. And these are all 97s here. How many options did I just list? Well, I went to 6 here, so you might think there's 6 options. But there's also this 0 case, so there's really 7 options. And hey, now this is really starting to look like a pattern. 1, 3, 5, 7. So what I have to do is figure out how to take advantage of that pattern that I'm starting to recognize. So I see a pattern. So let's see, how about this? Number of tens and then number of options. If I have 100 tens, I had exactly one option. If I had 99 tens, I have 3 options. If I have 98 tens, I have 5 options. If I have 97 tens, I have 7 options. What I would like to know is how many options would I have if I had 0 tens? Kind of want to know where this ends. Well, one way you can do that is you can say these are all the odd numbers. And so I would want to know what is the 101st odd number. How do you figure the 101st? How do I know it's 101st? Well, because there's 101 numbers written over on this side, right? 100, 99, 98, 97, all the way down to 0. There would be 100, except I have the 0 here, which makes there 101. So there's 101 options over here. And these are all the odd numbers increasing. So I want the 101st odd number. Well, the first odd number is 1, and then 3, and then 5, and then 7. Each time I'm adding 2. So if you thought about this as 1 less than the number 2, and this is 1 less than 4, and this is 1 less than 6, and this is 1 less than 8, this would be 1 less than 202, which is 201. So I know how many options I have. My answer to the problem will be this sum. Right? I still have to figure out what is 1 plus 3 plus 5 plus 7 all the way up to 201. So kind of looking for another pattern, sort of a pattern within a pattern within a pattern. But I think we can do this. So my answer, maybe up here, is equal to 1 plus 3 plus 5 plus 7 all the way up to 201. And it's challenging to sum that up. But what I could do is I could write them again backwards, 201, 199. It's hard to read. Maybe I got a better place to put this. Let's do it up here. My answer is 1 plus 3 plus 5 all the way up to 201. Turns out that when you're adding up odd numbers, you see another pattern there. 1 plus 3 is 4, plus 5 more is 9, plus 7 more is 16, plus 9 more is 25. Those numbers that I just listed out to you are all squares. They're perfect squares. But in case you didn't recognize that pattern, here's a way you could solve this problem using methods we've learned in our class. You could use a variation of Gauss's method. You could write this sum again right underneath the sum and recognize that every single column sums to exactly 202. And then you could ask yourself, well, how many columns do I have here? Well, we know how many columns we had here. We talked about that down here. There's 101 columns because there's a column for each number written on this side, and there's 101 numbers written on this side because I've numbered them from 0 up to 100. So I have 101 columns, each column summing to 202. So what I need to do is figure out what is 101 times 202. And if I could figure that out, I would have the sum of this entire thing, which would be twice my answer, right? Because I wrote the sum 2 times here. So I want to divide that thing by 2. Well, the 202 and the 2 cancel out, and that leaves me 101. So really it's just asking me what is 101 times 101, which I think I can do in my head. I think that's 10201. I think that works out. You might want to pull out a calculator to verify that thing. I think I just pulled out a calculator. It'll just take a second to open up here, maybe. At any rate, if my calculator ever opens, we can check this answer. There's my calculator. So I got 101 times 202 divided by 2. Hit enter. You get 10201. We'll talk about mental math later as this class goes on, how you could have figured that out without using a calculator. But for now, we'll call that good. So how many ways can you pay somebody this much money? 10,201 ways. It's a lot of ways, right? If you we're trying to list them out, you'd be here forever listing out 10,000 options. So really key to this problem was not just making a systematic list, but doing so by finding a pattern in your work as you go down here. I guess I'll call this good.